Okay, 4.4 problems in 2 dimensions. So example 1, a kite is flown at an angle of 60 degrees to the ground. Okay, so what that means is that there's going to be some kite, okay, and it makes an angle of 60 degrees with the ground. Okay, at the end of a 30-meter string, that would be the kite. Okay, so determine the height of the kite above the ground. So we would draw this as a right angle triangle, and we want to determine the height. So when we're taking a look at SOHCAHTOA, we want to discuss which one we would use. Okay, so we have 60 degrees as our angle, and we want the height, which is the opposite side. And then the other component that we have is the hypotenuse. So opposite over hypotenuse, we're going to use sine. So we're going to get sine 60 equals height over 30. Okay, we're going to cross multiply the 30 up. 30 sine 60 equals h. And then all you do is put that into your calculator. And we get a height of 26 degrees. We'll just round it. 26, sorry, meters. Okay, so therefore the kite is 26 meters above the ground. Okay, a submarine 500 meters below the surface of the water is directly between 2 ships. Okay, so here's the water. Okay, and if the submarine is 500 meters below, and it's directly between 2 ships, so the ships would be on the water. If the angles of elevation from the submarine to each ship are 38 and 51, okay, so this is what we're looking at. So when we say angle of elevation, we actually have to go from the horizontal. Okay, so the elevation would be here, 38 degrees. So then that would actually be in here. Okay, and then 51 degrees elevation, because we're going from the horizontal up. Okay, so because of the Z pattern, it would be 51 in here. Okay, how far apart are the ships? So what we're looking for is like, let's call this x1 and let's call this x2. Okay, so the first triangle that we're actually looking at is just this one, 500, 38, and we're looking for x1. Okay, so relative to the 38, the 500 is opposite and the x1 is adjacent. So when looking at SOHCAHTOA, I think to myself, well, we have opposite, we want adjacent, we're going to use tan. Okay, so we're going to go tan of 38 equals x1 over 500 over x1. Opposite over adjacent. Now, this question is a little bit harder because the variable is in the denominator. So we have to cross multiply that up. x1 tan 38 equals 500. And now we can divide both sides by tan 38. Okay, so we're going to get, these are going to cancel, and we're going to get x1 equals 600 and let's round, 640 meters. Okay, now the second triangle that we're looking at looks like this. Okay, so we have 500, we have the angle of 51, and we have x2. Oops, 2. So relative to the 51, we have opposite, which is 500, and we have adjacent, which is x2. So we're going to use tan again. Tan 51 equals opposite over adjacent. Okay, and if you notice from the last one, these two numbers actually like work on a line and they can switch. Okay, so x2 comes up and tan 51 goes down. So we have x2 equals 500 over tan of 51. And after we put that into our calculators, we get 405 meters. Okay, now at the bottom, so we have 6, 40, and 405. Okay, so this one is 640 meters, and that's from here to here. And then from here to here, we have 405. So what we're going to do is at the bottom, we're going to say, what is x1 plus x2? So what is 640 meters plus 405 meters? Okay, so 1,045 meters. So therefore, the ships are 1,045 meters apart. Okay, example 3, a soccer player takes a shot on a standard net that is 7.5 meters wide. So here's the soccer player, and here's the net. Oh, sorry, 7.3 meters wide. Okay, if the player is 10 meters from one goal post, so I'm assuming from this one, and 14 meters from the other, through what angle can the goal be made? Okay, so as long as the soccer player kicks on any of this angle, they're going to get the ball in the net, right? So this is going to be cosine law. We want to find this angle. So let's call this A, B, and C. Okay, so we want cos A equals A squared minus B squared minus C squared all over negative 2BC. Okay, so since we're solving for the angle A, we are going to do 7.3 squared minus B is 14 squared and then minus 10 squared all over negative 2, 14, 10. I'm going to calculate the numerator and the denominator separately so that you can check if you got them correct. Once you're really good with your calculator, you can probably put this entire thing in. Okay, so negative 2 times 14 times 10, negative 280. Okay, so we have cos A equals negative 242.71 divided by negative 280, 0.8668. Okay, in order to get the cos off the A, because obviously 0.8 is not the angle here, okay, we're going to cos inverse both sides. Okay, and we're going to get angle A equals 30 degrees. Okay, so therefore, there is a 30-degree angle that the player, or in which the player can score. Okay, example 4, a pilot wishes to fly an airplane due east. Okay, so they want to go east. Just remember, never eat shredded wheat. Okay, but a strong wind is blowing southeast at 100 kilometers an hour. Okay, so when we're talking about southeast, we're actually talking about like going south and then rotating east, and it's right in the middle. So this would obviously be 90 degrees between south and east. So each of these would be 45 degrees. Okay, so but a strong wind is blowing southeast at 100 kilometers an hour, keeps blowing the airplane off course. So this is where the airplane wants to travel, but there's some wind going like this, 45 degrees, that's blowing it off course. If the airplane has a cruising speed of 450 kilometers an hour, oh, by the way, this is 100 kilometers an hour. So this is a speed. Okay, in what direction should the pilot fly to reach the destination? Okay, so the pilot should actually fly this way because he's getting pushed down. Okay, so he'll get pushed down a little bit more, but he wants to actually fly east. Okay, and he's flying at 450 kilometers per hour. Okay, so taking a look at this, this would be 45, but then we'd also have this 90 degrees. Okay, so remember, like in this corner here, what I essentially did is I envisioned like never eat shredded wheat, right? Let's clean that up. Okay, so this one is 45, that one's 90. So essentially what we have here, and we'll keep it in kilometers per hour. We have 450, we have 100, and then this entire angle is going to be 135. So the question is, in what direction should the pilot fly? So the direction is going to be this angle. This is what we want to find out. So we have a matchup here. We're going to go sine of 135 over 450. And what we can do here is we can actually just solve for this angle first. Okay, so let's call it A. And we're going to have sine of A over 100. Okay, so what you want to do is we would just want to cross multiply this 100 up, and usually I put it in front of the sine 135 because this is a length, whereas like sine, cos, and tan have to be beside an angle, so I don't want any students to multiply like the length by the angle. Okay, so over 450, and this is going to equal sine A. So we have sine A equals 0.157. Okay, you can notice that's not an angle, but how do we get the sine off the A? Well, we're going to sine inverse. Okay, both sides. So we get A equals 9. Okay, and that one is going to be degrees. Okay, so if we go back up here, and I'll do it in purple, okay, if we go back up here to the diagram, this is going to be 9 degrees. So this originally here was 45, and if we do the Z pattern, this is also 45. Okay, so now we have an angle here of 54. It's going to be the 45 plus the 9. So what we can do is we can describe this as, again, the never eat shredded wheat. So self, and then rotating 54 degrees east, okay? So therefore, the pilot should travel in the direction of, and then we can quote it as starting south and then 54 degrees east.